Good morning, everybody. Hey, I hope you're having a good day. Hey, welcome. Let's take a look what we're doing. All right, what we're working on is we're working on a review. Now, remember, here's the plan. We got to finish this unit, Unit 5. We'll finish Unit 5, take the test, and then we have the review and the final. Now, remember, the final is 15% of your grade. So even if you're getting like an 80% right now, if you don't take the final, you're at 65%. Okay? Because it's 15% of your grade. So don't forget. Be responsible for that. Take a look. Let's finish this review. Don't forget to submit everything. Last week, the quizzes. Make sure you submit the quizzes. And make sure you submit the homework. This particular one. Make sure you submit all this kind of stuff. Because the more, you want to just keep that grade up, but besides that, you want to make sure you're in this class to get that Harper credit. So make sure you get some credit here. Okay, so let's go. We're going to go over the second one first. Take a look at this one. We're going to go over the review first, just because it's been a weekend and we don't remember all that stuff. So let's go through this. Now, remember what this chapter is about. We're looking at patterns. There's different types of patterns. Okay, this first one, what type of pattern do you see? Well, let's see. I try linear first. And linear, remember, linear is adding or subtracting. So this goes up by 5. This goes up by 5. This goes up by 5. Up by 5. All right? That's linear. You see? Because the change, remember, it's all about the change. The change is up 5, positive 5. Let's check this one out. This goes up by 1. Oh, wait a minute. This does not go up by 1. So that can't be linear anymore. Let's see what this goes up by. This goes up by 3. This goes up by 5. This goes up by 7. Oh, that's a recognized pattern. Odd numbers. When the change is odd numbers or a multiple of odd numbers, like 2, 6, 10, 14, like 100, 300, 500, 700, a multiple of odd numbers, we said that was quadratic. So let's go to the next one. This goes up by 3. This goes up by 6. This goes up by 12. Oh, wait a minute. This goes up by 24. Well, that's not linear. Okay, let's see if it's odd numbers. Not odd numbers. Not a multiple of odd numbers, so adding's out. We tried our adding strategies. We tried to see if there's a pattern. That's out. Okay, but keep looking at the pattern here. This goes up by 3. This goes up by 6. This goes up by 12. See the change of the change. Oh, same pattern. Let's try it again. This goes up by 3. This goes up by 6. Oh, the change of the change of the change. When that happens, it's multiplication. Let me change pens here. Take a look. I multiply by 2. I multiply by 2. Multiply by 2. You see that? Times 2. Not adding 2, times 2. When I'm multiplying, it's exponential. Look at those 3. Those are the 3. We talked. Unit 3 was all about linear. Unit 4 was about quadratics. Now we're working on exponentials. So if this is exponentials, remember the formula? Y equals a times b to the x. Well, this looks like it's 2 to the x. Okay, so when we plug in 0, you can use your calculator if you need to. Let's get my calculator out. When it's 2 to the 0, we go 2. The to the button is right here above, right there. Above the divide to the 0 is 1. 2 to the negative 1 is 0.5. Now watch this. I make a math fraction. It's 1/2. Remember we talked about this pattern before. 2 to the negative 2. Math fraction. 1/4. Oh, look at that. Okay, now what do I see? Look at that. 2, 1/2. 4, 1/4. What do you think that one's going to be? Okay, this is going to be 1/8. This is going to be 1/16. You see that? The 4 is 16, so the negative 4 is not negative 16, it's 1/16. We call that the reciprocal. Do you remember those? Okay, look at the pattern still. Going this way, times 2, times 2, times 2. But going backwards, if it's the opposite of times, is divide. So we just divide by 2. divide by 2, divide by 2, divide by 2. It all depends on which way you're going. Just like linear, when we're adding and subtracting, adding going one way, subtracting going the other way, well, multiplying going one way. Okay? What is a positive number raised to the 0? It's always 1. Okay, how do you compute a number raised to a negative exponent? Now remember a negative exponent. If you know the positive exponent, you know the negative exponent. So for example, if I told you, if I used my calculator and said 2 to the 10th is 1,000, I just made that up, 1,024. What's 2 to the negative 10th? Not negative 1,000, it's 1 over 1,024. So we said they're reciprocals. That's the word reciprocals. Now we're just reviewing, so remember, we did this worksheets already, so you can take a look at your work before if you take a look at the notes of that. But we're talking about exponents. Just refreshing our memory here. Okay, let's go to the next page. Oh, oops, a little formatting. Sorry, I formatted that. Write a function that relates prices to the number of months that the product has been on the market for. Okay, the price of the product has been increasing at a rate of $2 per month. Okay, we make a table if that helps. It started at 3, so 0 month is 3. That's the y-intercept, remember? And it's increasing at $2 per month. So after 1 month, it's 5. After 2 months, 7. See, $2. 3 months, another 2 is 9. Okay, how am I changing here? I'm changing by adding 2 every time. Okay, so if I add 2 every time, that's a linear. The y-intercept is right there. The slope per month, remember we said that per is the slope. So y equals 2x plus 3. Linear. Now that should be a review for you. Remember, you can always pause the video, send me a question if you're stuck on something, or ask in chat if you're following along right here. But whereas the price of the product increases as a percent, now that percent's a key to exponents. Percent is multiply. Okay, so we make our chart again. 0 is still 3, but after 1 month, I take my 3 and I multiply by 0.02. So it increased by, and I'm going to add that 3 there. It's now $3.06. And we'll do it again. 2, I take that and I multiply by 0.02. And then I add it to my $3.06. And it's $3.12 and a little change right there, a little extra. Let's do it one more time. I take that, I multiply by 0.02. And then I add that to my previous one. Let me highlight the previous one. I'm adding it to my previous one. And I get 3.18 and a little change. You see that? Okay, now, we had a fast way to do it. We had a nice little formula because we had the starting value, 3. And remember, if it's going up, we called that growth. And it was 1 plus the interest rate, the rate. Okay, if it was decay, remember decay was 1 minus. This was growth. If it's growing, and this is decay, 1 minus 0.02. Now, both of them is still to the x. That's exponential. The x is up there. But remember, just refreshing our memory, all this is review. This is growth is adding. That's subtracting. Okay? So, what's the formula? Our formula is y equals 3. I'm going to put in parentheses 1.02 to the x. There's our b. There's our a. Remember those formulas. Y equals ab to the x. All right, when you use that, you get 3.456e. When you see that, you got to remember that. That's just the calculator. There's not a little person inside your calculator doing stuff. When you see something with an e on it, a e negative something, okay, that means 0 on the calculator. It's a really, 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 really small number. So you just got to remember that. That's all they're trying to get you on that one. If you see, like, for example, if I'm working and if I go, hey, what's 1 divided by 2, blah, 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 some big long number, it happens. You see how you get that e up there? Doesn't matter what this is. e to the negative, that's really close to 0. That's scientific notation, if you remember from your science classes and stuff. Okay, how's that looking? Let's see if anybody posts a question, or just send me an email if you're, working on something else now and watching this later. This is just review. We're going to review one sheet a day, and then when we're done, we'll have the test. All you have to do is turn these in. So all you have to do is put the effort into it. Let's take a look at these, the growth and decay. Make some points. And I'm just going to use my calculator here. 2 to the 0. 2 to the 0 is 1. So I'm going to make a little table. 0 is 1. 1 is 2. 2 to the first. 2 to the second. We know that one. 4. 2 to the third. 2 times 2 times 2. It's 8. Let me plot those points. 0, 2, 4. See how it looks kind of linear, but all of a sudden it shoots up right here. Let's go to the negatives. 2 to the negative 1. 0.5. So at negative 1, I'm kind of like in the half. And as we talked about, exponential growth looks like this. How did I know it was growth? This is a number bigger than 1. There's not a fraction. Okay, it looks like that. And decay is the other side. If we go 1/2, now remember when you plug in fractions on this calculator, you got to put in parentheses. 1/2 to the negative 1 is 2. Negative 1 is 2. 1/2, parentheses, I got it done 0.5 also. Oops. 1/2 to the negative 2 is 4. So at negative 2, it's 4. You see the pattern? It looks exactly like this. It's just on the other side. And we call this decay when it comes from the top. Okay, don't forget, remember, this was here, this line right here, right there. All of them have, it's called an asymptote. That's that horizontal line that you can't cross. It's like a border. You're coming down, can't pass it. And how are these related to each other? As we said, this is growth, and this is decay. Okay, there's our first 2 worksheets for the review. Take a look at those. And all you have to do, okay, you could ask questions, of course, but all you have to do is work through those and turn them in. Okay. Now, let's get to a little more advanced. This was Monday's work, just a little more because the last part we were talking about inverses from last week, so it's a good chance to review that again on inverses. Okay, use the data. Okay, so find a linear regression. Now, remember how we did that. Okay, we went on our calculator under stats, and we're going to edit. And let's go with the number of years. Let's say that's 0. So let's first clean this up a little bit. 1988 is 0, so that's 4. That's 8. You see I'm increasing? 12, just going up by, but now look at this one. Look at this one. How far is 2000? That's 17. Just be careful. And that's 22. You see what I mean? Just be careful about your numbers there, but we'll call that 0. And so we're going to go put in, let's see, 0, 4, 8, 12, 17, 22. Just pay attention to that. Let's delete all the extra stuff. Right? Delete, delete, delete to make sure we're deleting all that extra stuff. I should have cleared the list first. I'm going to do that right now. Clear the list. Enter. And then this part is 350, 138, 33, 4. And you guys are pretty good with this, just entering the data on the calculator. People are pretty good with that. Okay, so find a linear regression. Okay, let's first question, linear regression. So where is that? Okay, that's under stat, calc. Number 4 is linear regression. And we'll calculate it. And, hold on, Mike, this calculator reset the R's. Let me just put that in there, second catalog. This is just, you remember how this works. We got to go into the diagnostics and make sure the diagnostics is on. Forgot. Thought I had that on there. Must have cleared this. There, I turned the diagnostic on. Okay, let's do that again. Stat, calc, linear regression. List 1, list 2. And take a look. I got my R. Okay, so our linear regression, let me just copy it in here. Let's make sure you get the same value. Y equals negative 13.749. I'll round. X plus B, since it said linear, y equals mx plus b, 232.613. And r squared, the regression is 0.66. Okay? Well, 0.66, is that strong or is that not strong? What do you think about that? See, let's try a quadratic. You're like, maybe that's not as strong. Let's do the same thing, stat, but this time we'll go to quadratic, 5. And calculate. And quadratic, remember quadratic, y equals, and I got ax squared, so 1.42x squared plus b, I'm sorry, negative 45.196x, and c, again, 325. And what's r squared? The regression on this one is 0.96. All right, that might... People are like, oh, that's better. Remember, the best is 1. 1 is the best, or negative 1. So we're looking for the best. And let's try a same thing. Let's try a... Where is it? Oop, where'd it go? I should have put my glasses on. All the way down to 10, I think. 0. Exponential. Let's try an exponential regression. 0. Go to your exponential. And same thing, calculate it, and let's see what it says here. Okay, and we go y equals a285 times 0.77 to the x, and r squared is 0.97. All right. So between these two, that's how we tell what type of pattern it is. It's not linear. We're looking for the best, closest to 1. And between these two, exponential is the most closest to 1. So that's the equation we're going to use. We're going to use exponential. Remember, you got all these patterns here, and this is the end of the chapter. You just got to figure out which one is which. Okay, so... the number of polo cases in 2013, well, what would 13 be? If that's 22 is 10, 23, 24, 25. So 25 would be 13. You see that? And we got, let's plug in 25 for our example. We got 285.34. times 0.77 to the 25. And the prediction is only 0.4146 thousands of cases. Because we said, I mean, look at our choices. We plugged it into this one because we said this pattern is linear. I'm sorry, myself. This pattern is exponential. So we use the exponential equation to plug that in. Okay, let's go the other way. The other way is, remember, this means inverse. So this is saying the y is 0.001, solve for x. Okay, so let's see what that is. When the y is 0.001, okay, oh, just compute it. Let's just compute it. And something like this, we're going to have to guess and check here. We're at 25. Let's try, see how close we get. Let's try 30. Nope, still too much. Let's try 35. Getting closer. Let's try 37. A little, is that, how's it? Oh, it's an 8, so let's try 38. Just get close, 38. 1.13, closer. We want 0.001. Let's try 39. Let's try 40. You see, we just keep trying, keep trying. Let's try 42. Better. Try 43. Try 45. Close, really, really close. Try 47. We keep going halfway there. Almost. Let's try 49. Oh, scientific notation. So let's try back to 48. 47, 48. There we go. 48. You see how we just guess and check here? The 48. Now, what's 48 mean? Okay, well, 2010 is 22. Let's go to 28 would be 2000 at 6 more, so 2016. 28 would be 2016. So add a 10, so 2000, see if you got it, 2036. You see? 2036. And it was just guess and check, just trying to figure out the inverse. Remember, the inverse, we have the y. Here's our equation. We have the y, and we're trying to solve for the x. And half-life, what's half-life? Well, half-life, same type of problem as the inverse. I start at 350. What's half of 350? 350 divided by 2. I'd like to see when it's 175. Okay, so it looks like 175 is pretty close. Looks like it's pretty close. Let's see. Let's try, I don't know, 2. Let's try 2. And even past. So it's less than 2 years. Less than 2 years. See how we did that? That's a good review of all that stuff that we talked about. Now remember, if we're going too fast, you ask a question. If you're not here, you watch it later, send me an email. Okay, make sure you're talking through on that stuff. Okay, let's do a couple more examples. Okay, a person invests and it compounds annually. Okay, compute the amount of, okay, as a function of time. Well, interest, remember interest, we had the nice little formula, and it's that parenthesis one. Now, one, is it plus or minus? When you invest something in the bank, you gain money, so 0.10. Okay, so here's our starting value, gaining 10%. Remember, we move the decimal place over, and there's our formula. There's your amount. I'll use A for amount. So we start with 6,000, and there's our number. So in 10 years, okay, 1.1 to the x. You see that? Okay, so we got 6,000 times 1.1 to the, and it's a 10 years, so we put a 10 in there. And in 10 years, that's pretty nice. The 6,000 now becomes 15,562. Okay, when will it reach 10,000? Okay, well, here's the guess and check. Let's see when it will reach 10,000. Let's try 5. Close. That was a pretty good guess. At 5, we're pretty close to 10,000. Let's try 6. All right, passed it. So between 5 and 6 years. When will it double? What's double mean? Okay. Double means we have, you see that? Double means we have 12,000. So when will it be 12,000? All right, well, 6 was close. Let's try 7. No, close to 12,000. Let's try 8. Past 12,000. So between 7 and 8 years. You see that? Okay, now we can find it exactly, but right now we can find the intersection. Remember, we did the intersection on the calculator, but this is good. This is good finding the intersection. We could do that on the calculator. Let's just show that. Okay, we've got our, let's enter our equation in. Let me clear these out. We have 6,000, parentheses, 1.1, close parentheses, to the x. And we want to double, so we want 12,000. Now let's check our window. Don't hit graph yet. The 0 to 10, because we know it, we feel it's between 7 and 8. So 0 and 10, we could see it. But remember, we're going up to 12,000. So let me put 15,000 in there. You see that? Hit the graph. So there's our growth. See how it's looking exponential? Starting to pick up the curve, and there is our intersection right there. So remember what I did on the calculator. Second calc. Number 5, once again, second calc. and find the intersection. Just get close. And hit enter, enter, enter. And there's the exact number, 7.27. So you see, we were right, between 7 and 8 years, but the exact number is 7.27. Try it on this one. See if you could figure that out. Let's do one more example. How about, okay, it's exponential. And we have, okay, let's see, the annual consumption of frozen yogurt has decayed approximately exponential from 2.6 pounds per person to 1 pound per person. Let's make a little chart there. So we'll call 0, 1995, 2.6 pounds. And in 2016, how many years more? It's 11 years, 1.0 pounds. Make an input out. Oh, we did that already. Look at that. Instinct. We made the table and it worked out. Okay, use the calculator to find the model. Okay, we did that already. Stat. We just did an example. We clear the list. Clear both lists. And 0, 11, or not 0, enter 11. 2.6, enter 1.0, enter. You see? And it says use, so stat, number, calculate, and 0, 10th one down, exponential, and let's see what it says. It says A is 2.6, B is 0.91. Double check your work. Remember, you could pause the video and try it. Pause the video and try it and see if you get that problem. That's why, following along as we're doing it is very helpful. Okay, so it's decreasing. It's going down at a rate of, now, remember, we don't put this number down. It's not decreasing at 91%. It's 1 minus. Okay, so I'm going to get my calculator, and I'm going to go 1 minus 0.9168. And I'm getting 8.3, remember, we moved the decimal place, percent. You see that? So predict when it's going to be 0.5. Let's find exactly that. Okay, we go on the calculator. Let's plug in our equation. 2.6 times 0.9168 to the x. There's our equation. Oh, I should have cleared the old equation out. Sorry. Let me delete some of that. See, we got x to the x. Let's delete that. There we go. And my intercept, I want to see when it's 0.5. 0.5. And remember, we hit window. Okay, that was 11 years, so we're definitely going to go maybe to 20 years. I don't know. And it's only decimals, so we're going from 0 to, let's go to 3, because that's the y-intercept was 2.6. Let's see what happens. Here it comes. All right, and then we'll see the line. Oh, pretty close to the end. Let me make it a little bigger. Window, let's go to 30 years. Try it again. Have it come down this way. Let me get a drink of water here while it's graphing. There we go. We can see the intersection now. Second calc. Find the intersection. Enter, enter, enter. And the exact number your calculator should say after 18.979 years. And what do we say there? If the first year, always look back at the problem, is 1995. So I go 1990. Let me go back and just calculate 1995 plus 18.9 years. I'm close to 2000.9. So I'm about 2014. Somewhere pretty close to 2014 is when this is going to happen. All right, so that's using the calculator. That was pretty heavy on using the calculator. The test is going to be on these. So start working through those. Okay, tomorrow I'll let you work on these reviews, and then on Thursday we'll get together and put them to work on them some more. Okay, so don't forget to look at these. Don't forget to turn in your old stuff, and have a good day, everybody.